in listen-only mode.
Good afternoon. Welcome to the PASS virtual chapter for Database Administration. My name is Julie Blomquist. I'm your moderator today, and we're going to be having a talk by Grant Fritchie on query performance tuning for Azure and SQL database. Our meetings are sponsored by Dell, and they also are giving us the funds to be able to do the raffle drawing at the end. We have some SQL Saturday events which are coming up in March and April. Keep these in mind. It's a full day of free education. The only fees involved usually just cover a box lunch. The past virtual chapter meetings are throughout the month. Here's the ones which are coming up for March. And we're also doing a special program. It's the SQL Server 2014 launch webinar series. So based on different dates, there's different lectures which are occurring or have already occurred. And here's the full listing of the past virtual chapters. You just go out to your past membership and you would add it to your membership, and when a meeting is coming up, you would then get the email notifications and the link notifications on how to attend the meetings. PASS also has a volunteer recognition program for the outstanding volunteer. So if you're aware of anybody in your area or with your local user group, which is a PASS member, you can make submissions at any time to give them the recognition for their volunteering. There is the Business Analytics Conference coming up May 7th to the 9th in San Jose. Please keep that in mind. We do have a discount code available. It's the BAVC08, so you could use that when you register. And I don't remember the exact reduction that you get or discount, but keep the Business Analytics Conference in mind. Like I said, we are part of the PASS organization, and you can sign up for a free membership, and there's good information out there, blogs, as well as the different virtual chapters. And we do have a SQL Server conference, which is coming up again in November in Seattle this year. Today, again, it's query performance tuning for Azure and the SQL database. Grant Fritchie is joining us. Grant's a SQL Server MVP with over 20 years experience in IT, including time spent in support and development. He's worked with SQL Server since 6.0 back in 1995. Well, he beats me. I did 6.5. He has also developed in Visual Basic, VB.NET, C#, and Java, and has written many books for Press and Simple Talk. He's joined Redgate Software as a product evangelist in January of 2011. He has some fantastic books, and those the Redgate books are available through ebooks, and they're very helpful. So I'm going to
free to download.
Free to download. So I'm going to turn this over to you. Whoops, Grant, questions, polls, attendees, staff. So I'm sending you over to be the presenter. Welcome. Thank you, Grant.
No problem. Should be seeing the screen now, I hope.
Yes, I do.
Okay, cool.
Looks good.
All right, so we'll get started. Query performance tuning in Microsoft Azure SQL Database. No longer called Windows Azure SQL Database, now called Microsoft Azure SQL Database. So which means the short term for it now is MOSD, not WASD, which will confuse no one, I'm sure. Anyway, let's get started. The goals today are pretty simple. I do want to talk to you about why you're going to be doing query tuning inside of the Azure database environment. There are very important reasons why. The big one being you save money. You can save your company money, which is really cool. I'm also going to show you the hybrid tool set that we use, because you don't have to just do stuff in the cloud, and you may not want to just do stuff on your desktop only. So you've got options. And then I'm going to show you a lot of the information that you can get through the management portal interface, and we're going to go over these things. And the beautiful thing is that the one thing I can emphasize over and over again, by and large, if you're already doing query tuning, the knowledge you have transfers more or less directly. The stuff you can do, the tools that you do have, are going to be very familiar, and you're going to know what you're doing very quickly. This means that your uptime to get going on these things is fast. So if nothing else, I hope that I can reassure you that if you do go in this direction, that things are going to be okay. You don't need to worry. All right? This is my contact information. Please use it. Get in touch. I've already gotten a great intro from Julie. Thank you very much. And I'm not going to go into all the details of what I do. I do work for Redgate Software. This is my contact information. If you have questions, let me know. I love answering questions. I want to help. It is my job. It is my passion. And now you have the means to get in touch and ask those questions, whatever that may be. So, oh, and I'll put that slide up again at the end. Don't feel like you had to write everything down immediately. So, here's the deal. If you're talking an Azure database, a Microsoft Azure SQL database, you don't have the control that you are used to having. When you're running local machine stuff, or even running local VM stuff, you can tell your queries which server they're going to run on, and you'll be able to do that. You can decide specifically how much memory is available, how many CPUs, how fast those CPUs may be. You get to pick and choose disks. You can decide on SANs. You can decide on networks attached storage. You can pick and choose how those disks are configured. And you pretty much have some control over the server being there, being available. When you move into Microsoft Azure SQL Database, and by the way, I'm going to stumble over that a million times because I've rehearsed saying Windows Azure SQL Database quickly and smoothly, and now I can't say that anymore. I have to say Microsoft Azure SQL Database, and that's hard to say now. I'll get used to it eventually. Anyway, if you're running a Microsoft Azure SQL Database, you don't have any control over where your queries are running, how many resources you get, CPU, disks, whether or not those things are dedicated to you. Now, there is a thing called Premium, Microsoft Azure SQL Database Premium, that lets you put a little bit more memory, lets you put some CPU in, and you get some level of control, but not like you're used to. That control that you're used to having is gone. Here's the deal. Because most of your performance problems are either structure or code related, those same structure and code issues that you have locally are going to translate up into the cloud, right? Just because you're running out on the cloud, it doesn't make fundamentals go away. In fact, it makes fundamentals more important. So you're going to have to take these things into account. Further, one of the biggest strengths, and I'm going to talk about the strengths in a minute, one of the biggest strengths behind Microsoft Azure SQL Database is the ability to run lots and lots and lots of databases all at once, to shard your data across these things in a completely expandable manner, which means a badly written query can be badly written and badly running in 10, 100, 1,000 places. You don't want that. So all of these reasons are why you're going to spend time tuning queries. You need to. It's not like it is on the old days where you could just throw hardware at the problem. You're not going to be able to have that level of control here. So you're going to have to tune queries. So then the question is well, okay, if I've got to do all this extra work that I never had, if you're taking away control, why on God's green earth would I use this silly thing? Well, let me tell you a few reasons real quick, and then we'll get into the fun. It's inexpensive. You're not paying for servers. You're not paying for licensing. You're not paying for electricity. Your costs go way down. You're not paying for OS licensing. There's You're not paying for system administrators to set up your operating system. Your costs drop. Speed of delivery is insane, especially when we're talking SQL database. You can provision and launch these things in a matter of seconds to minutes. They are fast. So you can add a database, add a database, add a database, and keep adding databases. They are wonderful, quick, very, very fast. And because you only pay for what you use, it keeps the prices lower. And because you only pay for what you use, you decide, hey, you know what, we've got a big thing coming up. We're going to need to collect a whole bunch of data that we don't normally collect, so we will expand our capacity. When that is finished, and we will pay for that, we will then shrink our capacity back down to a lower portion that we will only pay then for what we need. Whereas in the hardware days, what you have to do is like, oh, we've got this new thing coming in. We're going to have to get expandable capacity. You go out and buy tons of hardware. It expands and stays expanded forever, right? Then you've got to find uses for those machines, justify the costs, all kinds of stuff, and you may just be spending tons of money that you don't need to spend. So businesses get real excited about this. When someone comes in and shows your CIO or CEO the way these cost structures break down, they get jazzed, and you begin to see things. The speed of delivery is also going to drive it from the other direction. Your developers are going to be able to see these things pop up instantaneously and go, holy crud, I don't need a DBA anymore, and off they're going to go. And every time someone says, oh boy, we don't need the DBA anymore, I rub my hands together with glee because it means more query tuning for me, and I love query tuning. All right, so any questions just on the basic concepts of why you may need to tune queries and why you might want to use SQL database? Because other than that, we're going to start moving into all the really cool stuff on tuning queries within MOSD.
No questions at this time.
Okay, great. So here's the fun bits. Some of us are older. As was just mentioned, I've been working with SQL Server since 6.0, so I'm an old guy. And as an old guy, I remember when we used to worry about transaction length because our network bandwidth was very narrow. We needed to keep transactions as short as we could. And because our network bandwidth was very narrow, we only moved the data we needed to move. We didn't do select star from table without a where clause just because the pipe will never notice. We moved only the data we needed to move. And we only moved the data when we needed it. You didn't do huge queries just in case. All of these things are back. Because we're now on the network, you want to try to keep your transactions as short as possible. Yes, your bandwidth is wide, but it is not infinite, right? The internet does slow down at times. You only want to move the data you need to move. Why? Because if you moved extra data, one of the costs of Microsoft Azure SQL Database is moving data out of the system. Now, if you're storing data up there and you're moving it between a web app all within Azure, you don't pay for that. But if you start running queries to move the data down locally to your own systems, you pay for those moves out of Azure. Those costs add up. So you want to keep those down as much as possible. Same thing for when you move the data. So you definitely want to tune your queries because tuning the queries uses less resources, uses less memory, makes things run faster, move fewer data, move data only when you need it, keeps those transactions as short as you can, and gets things going to where you need it to go. And that's the whole goal. You've got to be able to control those things to make things run the way you want to. And one of the things, I don't have a bullet point for it, I probably should have, that network can go away. So one thing you need to add, which is not necessarily query tuning, it's programming, you need to add retry logic because you will see things go away. Now, speaking of going away, let's talk about specifically why you want to tune queries to save money. There is this thing built in to Microsoft Azure SQL Database called throttling. Now, Microsoft has gotten better and better with the throttling. They throttle less and less all the time. But think about it like this. These are databases. They're not servers. They are databases. Each of these databases is in a shared environment with other databases. You don't want to be next to somebody who's got horrifically written queries, tables without indexes, performing scans all the time, running select star without a where clause, moving every single bit of data they have to move every time they move it, and doing it in some inefficient fashion. So Microsoft says if you use too many resources, if you use too much memory, if you use too much TempDB, they will throttle you. Throttling, well, it sounds like that little picture you see where 3 arrows get turned into 1, but really what it comes down to is they kill your connections. If you exceed the usage on CPU, if you exceed the usage on memory, they will kill your connections. Now understand, the numbers that you have to hit to exceed the usage of memory, the numbers you have to hit to exceed the uses of CPU are extremely high. You've already done something foolish, is the best way I can put it, with your query or with your structures. If you're hitting throttling, in most cases, that's what's going on. Now, there are some instances where you have long-running queries due to locking or blocking, where you're doing, and here's my favorite, you're doing index rebuilds on bigger tables, and by bigger I mean very much bigger inside of the Microsoft Azure SQL database space. You can get throttled on index rebuilds, which is painful. Now, what does all this have to do with money? Well, let me ask you a question. If you've got a long-running query, run from user data, from a user screen, from an application, and the query gets throttled, the connection gets killed, what do your users usually do? They hit retry, right? So you've just moved X amount of data out of the system, you get killed, they run retry, and it moves that same amount out again. Now, I don't know about the people you're used to working with, but the people I've worked with will probably hit that retry button 3, 5, 8 times before they give you a call. They'll probably be hitting it while they're dialing you. They'll probably be hitting it again while you're on the phone with them. Every single time, moving data out of the database, costing you money. And then getting throttled, connections killed, and then they retry. So throttling needs to be monitored, and that's the first thing you want to be able to look for is the ability to check on throttling. Luckily, we have this. There's 2 dynamic management objects built into Microsoft Azure SQL Database, sysEventLog and sysData Connection Stats. Now, sysEventLog has got, it shows throttling long transactions, it'll show deadlocks, and it has an event subtype which shows you the actual reason and a description for why things occurred. And then you've got the connection stats, which is an aggregated connection info on 5-minute intervals. And so it shows you the different levels of throttling as you run queries against it. Now, you do have 2 levels of throttling. There is what's called a soft throttle and a hard throttle. But the interesting thing is that both those levels of throttling result in killed connections. So I kind of don't differentiate between the two because it effectively doesn't matter. Now, some of the things, for example, a long-running task, the time amount is 20 seconds. Or a session consuming too many locks is 1 million. I mean, if you're consuming 1 million locks on a query, you've already done something wrong. If your session is consuming too much TempDB space, 5 gigs or more, you can get killed. If you're consuming log space, transaction log space, if you're consuming 16 megs of memory and you've got a 20-second wait, you can get killed. So, I mean, these are, if you think about it, these are all pretty acceptable limits, really, for most queries most of the time. It's just when you hit those edge cases, you're going to get throttled, and then you have to worry about those and get in and do some query tuning. All right? Any questions so far, Julie?
We have one. 2. Does this SP or the store procedure run as a single transaction on Azure?
Does the store procedure run as a single transaction on Azure? I'm not sure I understand that question, but it does run as a transaction, yes. The one thing to remember about the Microsoft Azure SQL databases is while they are databases, not servers, under the covers in areas that we can't see, it is still SQL Server. It's just a different flavor of SQL Server with some different code. But it is still effectively SQL Server, and so most of the concepts that we're used to working with, such as transactions, they're still there.
Okay, the other is, how do I check the log space consumed by my queries?
How do you check the amount of log space assumed by your query? Off the top of my head, I don't have a good answer for that, so I'm going to plead stupidity, say I don't know, and it's something I'll have to look up. I'm sure there is a way to get it, but it largely has to do with how big and how many transactions you are doing inside of a single transaction determines how much log space you're using. So it goes back to, like I said, that first basic rule: keep your transactions as small as possible.
And then how about an open transaction? Is it automatically killed too?
Oh yeah, when it kills the session, so that transaction is going to go into a rollback.
Yep, that's it for now.
Sure. Okay, so let's talk tools for query tuning. You get three basic tool sets. You've got SQL Server Management Studio, which hopefully you guys are all familiar with. You've got the SQL Database Management Portal, which is on Azure, out on the web, and then you've got dynamic management objects available from both. Let's drill down. SQL Server Management Studio. First off, and this is a silly thing to say, but I like to point it out, you must have connectivity out to the interwebs, right? If you cannot get to the internet, you can't use SQL Server Management Studio. And I do know that there are some companies that curtail or limit internet connectivity from inside of the company. Now, I think those are going the way of the dinosaur. I sure hope they are, because I don't know how I could get my job done if I wasn't connected to the internet all day long. And that's not even counting being on Twitter. You can use, inside of Management Studio, you can use the Objects Explorer. You get stats.io, stats time, exactly as you would expect. You absolutely have full sets of execution plans. And you get a query window. Now, there are a few tools I did not mention. Some of you hopefully are already thinking, well, wait a minute, what about Profiler? Well, one, don't be running Profiler in your production systems. Run trace events on your production systems, not Profiler. But do you have trace events? No. Do you have extended events? No. How do you track queries? Guess what? You kind of don't. What you do have is you have access to the DMOs. I'll show you that in a minute. But you don't have trace. You don't have extended events. And here, let's just switch over. Let me show you Management Studio. You can see that, right, Julie?
Yes.
Cool. Right, so this is Management Studio. I'm connected up to one of my Azure instances here. This is, I've got, what you're seeing there is actually two Azure servers and then my local server. You'll see databases, security, and management, and that's all. Nothing else. If we look at my regular server here, let me zoom back out, you'll notice we've got databases, security, server object, replication, always on, and each of those is drilled down to more information. None of that exists. None of that exists in SQL database. So all we have is this. Security is just logins, and databases are the databases we have available. So I've got my movie management database here. It's the one I'm playing with. I've also got a Redgate Cloud Services. But these are both databases on the local server. Now if I drill down, you do see that I've got tables, views, all that kind of stuff, and I can continue to drill down. Now, interesting point, if I right-click on this and hit New Table, I get a script. I don't get a GUI. There's very little of the GUI interactivity within Management Studio. Practically none of the GUI activity is available within the Microsoft Azure SQL database. So you're going to have to get used to running a lot of T-SQL code, right? But let's put up a new query window just to show you. Most of the standard stuff, like if we want to do, you know, SSF, and we wanted to say pick the movie database, we can drag and drop to pull that over there. If we wanted to add columns from that database, we can get down here into the columns and drag and drop those. So most of the standard mechanisms that you've got are still available. If I do if I right-click on it and go to Query Options, I can go to Advanced, and I can set Statistics I/O time on and off, or I can do, you know, set Statistics I/O on, right? Works the same as before. You can do those, you know, in either way you want. If you run the query, it will execute. You get results back. You get messages back. It's pretty much, you know, the query that we would expect to see. Now let's close that down, and let's take a look at another query over here. Oops. Cool. I always time that right. I'm glad I did. If there are idle connections, right? I connected this up prior to doing the presentation and left it there, and I actually do this every time on purpose. If there are idle connections, you will get errors. It will disconnect those, and you will get errors, and you'll have to have retry logic built in to make sure that you can retry those. Beautiful thing is there was nothing I had to do. I just said, okay, try it again, and it reconnected. I get back the results I expected to see. I get back the messages. But let's take a look at this. What if I want to, oh, I don't know, take a look at execution plans, because I love execution plans. Well, we'll hide this so we can see. We've got a full-blown execution plan, and this is absolutely, you know, pretty much what you would expect with an execution plan. Let's pin the properties open so we can see them. If we take a look at the nested loop property, it's all the stuff you would expect to see. If we take a look at the select property, you can see that we've got, you know, good enough plan found, optimization level is full. You know, it's completely the stuff we expect to see from the execution plan. So our tool set for fundamental tuning is intact. We get stats IO, stats time, we get execution plans. What we don't get initially is that ability to track queries individually through trace, through extended events. I'm sorry, it's not there. Does Microsoft have plans to do it? I don't know. I am sure they're going to do something at some point, if only because as adoption of this grows, it's going to be something that we need, right? We need to be able to see the longer running queries or the more frequently called queries. So they're going to have to implement something. So it'll be there at some point. But that's the basic tool set, right? You've got execution plans, stats IO time, the Explorer, and the query window, and off you go, right? Any questions at this point?
Hold on a sec, let me. There's around 100 sleeping connections existed in a server. Is it good to kill those that are no longer needed?
Well, in a traditional server, no. I would not kill them at all. In an Azure window, I can't even say it anymore. In a MOSD database, if they're completely dead connections, they will get killed for you. You won't have to worry about it. If they're not being used, they will get killed. So you don't have to either way. No, I would not kill connections. Not as a general practice.
And what do I do to allow IntelliSense on the Azure database?
Oh, you don't. What you saw was not part of traditional. That's something else I won't talk about. You can't. It doesn't work.
Okay, that's it for questions.
So, yeah. All right, let me go back to the slide deck. All right, let's talk about the management portal. Now, the management portal it's Windows, right? And it has some additional stuff. It's a little bit different. You've got some monitoring built in. Some of it's good, some of it isn't. You've got a query window, stats IO, stats time, and execution plans, all on the web. The monitoring is limited, okay? No other way to put it. It is quite limited. You can see connection activity, including throttle connections. You'll be able to see query performance, both aggregation and details on the queries, through a nice little GUI that we're going to play with in a minute. But the thing to remember is that it is completely dependent upon the cache. This is not real-time collection through trace. This is not real-time collection through extended events. These are queries against the dynamic management objects, which means it's completely dependent on cache. And the thing about cache that you also have to think about is that, again, we're talking about shared servers, right? It's not one database running on that server. It's not 20 databases running on that server. It's not 100 databases running on that server. It's probably 500 or up databases running on one server, shared. They are also sharing memory, which means cache inside of the Microsoft Azure SQL database environment is volatile, extremely volatile, which means certain queries may go in and out of cache very quickly. You may never see them through the monitor. So it's just something to be aware of, something to think about. Let's go over and play. Now here we are. This is the movie management database again. I'm just going to show you the dashboard. And we can see connection information. It's going to show us deadlocks, and you can see when I logged in this morning, started playing with stuff, and we can see what's going on. Now, I don't have any failed connections. I don't have any deadlocks because everything's set up. Plus, I did a bunch of tests yesterday, so we can take a look at that, but we're not going to. Right now, what we're going to do is log in live. And yeah, you do have to use SQL logins for this. No, at this point, no AD logins. And here's my basic thing. I can see my summary of the setup on the server. We'll zoom in a little bit so you guys can read it a little bit better. I've got a very small database here. It's 5 gigs, and I'm only using 5% of the 5 gigs. I've got a few connections open. I've got one active user. Pretty, unexciting stuff. Let's take a look at the query performance, because that's what I promised you get to see. So this is a query against the system to see what's in the cache. Now you can see the query I ran earlier is right there. It was still in cache. I had a run count of 2 because I ran it twice, once to get the query, once to get the execution plan. So that's still in cache. It hasn't aged out yet, which is great. You can see I've got run counts, I've got CPU, durations, physical reads, logical reads, and all this stuff can be scrolled through and sorted. So I could sort by, well, let me see, which one's doing the most physical reads? Oh, I don't know. Which one's doing the most logical reads? Well, there we go. Which one's doing the logical reads per second? You know what I mean? You get to break it down that way. You can also drill down. We'll click on that one query that we were already familiar with, and you get to see, the query itself pulled out of cache, and then the durations, CPU, logical reads, physical reads, all that kind of stuff. We also get some additional information pulled, again, out of cache. Nice, handy to have. Run count, last time it was run, when the plan got put into cache, and the plan handle, SQL handle, query hash, and plan hash. So if I want to run queries against the DMOs to pull back additional information while it's still in cache, remember, I can go there and get this data right here real fast, and then go to town and start pulling that stuff in. But that's really all we get. Now, as I said, there is a query plan, and as you can see, it looks exactly like the query plans we're used to looking at. So we're going to go on from there. Any questions about the standard portal monitor? Just the monitor bit. We're going to get into some other pieces in a second.
No, I don't see anything on the monitor.
Okay,
Thanks.
Cool. So the query window. Query window is basically SSMS, right? It's a query window. Of course, it has no code completion, including from third-party products, at least at this point. That may change in the future. We'll see. There is no drag and drop for the object names, as I showed you within SSMS. You don't have properties, but you can still use set statistics time on and off. So you're not limited in getting those things put together. And you do get execution plans, both actual and estimated. So let's switch back over there and play with the queries too. So we've got right here, new query. What we can do is just go to open, and where is it? Add presenter. We can open the same file that we had opened in the other place, right? And so then we can highlight this query. Now, don't hit F5, don't hit Control E. It's a habit. I want to say it to everyone because it reminds me not to do those things. If I hit run, then I get to see the query. Now I can go back over here and hit set statistics IO on, and then we will set statistics IO off. Never type in demos. There we go. Hit run again, and we can look at messages, and we will see in the messages there's our IO exactly as it would be over here. Right? No difference. Reads, scans, all exactly the same. And if we go back over to the Azure, here it is. There you go, reads and scans, all exactly the same, no differences, because it's SQL Server. We're just using a slightly different tool set to pull that SQL Server. I can look at estimated plans, I can look at actual plans, and I can see what's going on with them when I run the query, right? And then it will show me the query plan, and as you can see, it looks exactly the same as it did before. And that's all I really want to talk about right here. We're going to get into some more details in a minute. Any questions on the query window?
Let me look through. No, not on the query window, just some other questions.
Okay, great. If any of them seem repeated or really important, just go ahead and shout them out. We can try to cover them. I'll try to finish up so we have plenty of time for questions at the end. So execution plans. As you guys have already seen, you have execution plans. They look exactly the same as what you're used to seeing because they're graphical. These can be exported as .SQL plan files, and as .SQL plan files, they can be opened up inside of Management Studio, or you can even use third-party products. SQL Sentry Plan Explorer actually works just fine with these .SQL plan files, so you can go in there and dig into those things. You do have properties on all the operators, as I showed you the properties before, and you've got this really cool thing I call highlighting. Microsoft calls it sorting. I don't see it as sorting because it's not literally sorting something, it's highlighting something, but let's explore it because it'll make more sense. Now, I've said this multiple times, and I kind of, I mean, when I'm presenting in real world, people will call me on it. You guys can't because we're remote. That doesn't look anything like the other execution plan. I kept saying over and over again it looks identical, but they don't, right? It's different, but not really. That's a select operator. These are 3 nested loop joins, and these are 4 seek operations. And I know this, 1, because I've done this presentation a few times, but 2, because I can zoom in and see what they are. Now, I like this functionality. This is pretty cool. It gives you a lot of control over what's going on. Now, you can scroll around still, just as before, no surprises. You get to click on these, and it will bring up a basic property sheet, more or less like a tooltip. And frankly, it's about as useful as a tooltip. The select operator is one of the first operators you should look at in an execution plan for a number of details in the property sheet, which you can't see here. So you have to click a second time, View More, and then that brings up the full property sheet, and you can see things like the set options, which are extremely important. Good enough plan found, reason for early termination, the actual statement, estimated cost, plan size, compiled memory, all that fun information that you use when tuning queries is all there, and you can get it. Same thing with the nested loops. Some of the information there is useful, but by and large, you're going to go to View More and drill down. But you can keep going from there. It works exactly the same. All those properties the same. Now here's some new things. Sorting, right? You can sort by CPU. Now notice, let me just zoom out just a little bit so we get the full plan in there. There we go. Now notice, this is total cost. This is total estimated cost. And these are the 2 highest operators. But if we switch to CPU, well, then you got a fairly even distribution. The CPU costs between all these seek operations are about the same. But if we look at the I/O costs, well, they look about the same too. But the total cost, it suddenly skews to these 2, and that's probably because the actual I/O cost down here is a bit higher than these 2, if you get into the details. Some other fun bits. You can look for and identify all the seeks, right? So now if you're looking for seeks or merge joins or scans or hash joins or, there we go, nested loops, sort operations, all these things can be identified so you can, when you're way out here, come on, go way out there. There we go. You can find these objects much faster. It's a great little set of functionality. I actually like it a lot. I think it's going to make a big difference in the way things are used. It's handy. There's reasons why if I wasn't using, say, a third-party product to explore a plan, I might go here rather than SSMS because it will make things a little bit easier. There's some other fun bits too, built right into the plan. You don't have to change anything. You don't have to rerun the plan or get anything else. You can get a different view of the plan. Now this looks like the old text plans really, and it shows you in order operation, you know, and that's the logical operation order, meaning left to right, not right to left. It shows you all the operations, and you can sort them. So you can say, well, hang on, which one has, you know, estimated CPU cost the highest? Well, now we can sort that. Well, which one has the highest I/O cost? Well, okay, there we go. And there you see that one column index seek. It actually had a slightly higher CPU cost and not a slightly higher I/O. I got those backwards. Interesting. But anyway, you can see the average rows. You can see all kinds of fun stuff, and you can sort it back to node. This is pretty handy little way to go through, especially when you get into very complex plans. It's nice detail on the objects that you don't normally get. There's also another view. This is what they call the tree view. I'm not a fan. To be completely blunt, I kind of see its use because if you're used to reading, if you do like that text plan look where you get this little nested view, then here you go. You've got it. You can kind of get in here and take a look at what these operators are doing and understand. And unlike the text plans, you can actually roll these up so that, you know, you're looking at less information, which makes it, you know, just a little bit easier to deal with and a little bit easier to read. I don't find it myself terribly useful, but I think it's cool that they put it in there, and I think it's also nice that you know, the people who will find it useful have now got an extra tool that they can put to work. But I will probably still mostly work in here or run XPath queries against the XML. Those are, you know, just most of the time probably what I'll do. I don't doubt that I'll probably come over to the grid occasionally and do sorts there, but more often than not, I'll just be looking at the graphical plan and then, when necessary, running queries against it. Any questions on this?
No, just a few general questions.
Okay.
As far as can they host SSIS and SSAS
Nope.
in the cloud? No. Okay.
No. Well, okay. Take that back. We're talking Microsoft Azure SQL Database today. You want to talk Microsoft Azure virtual machines? Different story. But that's just a virtual machine. And if you have a virtual machine locally and you're running SSAS on that virtual machine, you can run SSAS on your virtual machine in the cloud. Same thing.
Okay, and do we have a baseline on the management portal? Otherwise, how do we know what our baseline is?
No. Your baseline is your baseline. You will need to gather those details so that you know what you're looking at. There's no other way to do it.
Are the statistics set to auto-update?
Yeah, it's SQL Server. Most of the standards are still there, and it's all going to operate roughly the same way as it does now. You may want to actually do manual updates on the statistics and stuff yourself, and so that doesn't really change. All right, let's move along so we have more time for questions because I want to get through the last couple of things. There are some differences when you talk about dynamic management objects, and it's worth noting. They are reset. There's no reboot, restart, attach, detach. Those things may be occurring behind the scenes, but we can't see them. We don't know them. What they are done is on database move. So the one thing to understand is the whole Microsoft Azure SQL database. The concept is that there is not one database. That's a virtual state. There are actually 3 databases in the background with the data maintained between all 3. If one goes offline, you automatically pick up on one of the other 2. Every bit of operating system information that you're used to retrieving through the dynamic management objects is gone. There is no more OS stuff. So think about any of the OS dynamic management views you're used to using, such as, oh, I don't know, sys.dm_os_weight_stats. Yes, there is no operating system weight stats available. None. All right? You don't get it. You also can't click on the execution plans, meaning when you run a query and it brings back the little grid, and the grid has got the XML for the query plan, you can click on it, it opens the plan. You actually have, you click on that, it will open an XML page. You have to save that as a .SQL plan. It's a tiny thing, but I find it to be a pain in the bottom, so I point it out as one of the DMO differences. Now, having stated that you don't get OS weight stats, you do still have the ability to do weight stats monitoring, because you can look at sysdm exec requests, which absolutely shows weights, and we've got a new new DMO that is Azure only, sysdm db weight stats. And yeah, I've looked at the CTPs from Microsoft, and it's still not there. We only have OS level weight stats. We don't have database level weight stats. I don't know why they wouldn't port that over. Maybe it'll be in the release that comes out in 2 weeks, or gosh, 5 days. I can't wait to see if it's there, because I think this is awesome. The ability to look at a single database and get its weight stats and not look at all the weight stats for the operating system is wicked cool. But right now you only have that in Azure. Now there's some special weight stats I want you to be aware of. There's the SE-REPL weight stats. The 2 most likely ones you'll see is SE-REPL slow secondary throttle and SE-REPL commit acknowledged. Those are related to those 3 databases. Remember I talked about those 3 databases with data maintained? It's using a thing called REPL. We can assume that means replication. I don't know, but it's not the replication that you and I know. It's not the replication that we administer. It's the special thing that Microsoft's doing behind the scenes. But anyway, these 2 weight stats is something to keep an eye on. Slow secondary throttle is due to secondary machines causing weights while the information is transferred over. And the replication acknowledged is, the communication between the 2 or 3 machines is slowing down. When you see these weights, you've got to assume one of 2 things. Either you have a noisy neighbor, or you're moving too much data and you are a noisy neighbor. You will know that you're the noisy neighbor if you're getting lots of throttling. If you're maintaining checks on your system for throttling, remember those throttling DMOs that we looked at earlier. If you're maintaining checks for throttling, then you'll know whether or not you're getting throttled regularly. If you're getting throttled regularly, you're a noisy neighbor. If you see these weights and no throttles, then you have a noisy neighbor. In which case, I recommend you call Microsoft and say, I suspect a noisy neighbor. And what they will do then is go in there, find the noisy neighbor, and kick them off the server, which implies that someplace there's a ghetto where all the noisy neighbors land. I don't know if that's true or not. I'm making that up, but it still. Anyway, they will kill that other connection, and you will be able to speed up your processes because you won't see those weights anymore. Other than that, you look for the standard weights, resource semaphore, I/O latch, SOS scheduler yield, showing memory, I/O, and CPU, right? So it's normal stuff. It shouldn't be any shocks there. The only thing special is the fact that you don't have the OS weight stats. You do have the DB weight stats, and you want to look for those special weights. I'm going to keep going, skip past this one just so we get through everything. The query DMOs are exactly the same as the ones you're used to dealing with. No difference. System exec request shows you the stuff that's running. System exec query stats shows you the stuff that has run but is still in cache, and it's a cumulative, an aggregate. You get to see DM exec SQL text to see the queries, query plan, and query plan text as methods for pulling stuff off. Just don't forget that except request is live, but everything else is cache dependent, and so cache is volatile, and that stuff may age out quickly. Index DMOs, exactly the same. Operational stats, physical stats, and usage stats. Operational stats showing you what's going on, physical stats showing you the behaviors, and usage stats showing you which ones have been touched or used. And you can query these exactly the same way. Fragmented indexes does add to storage overhead, right? The more fragmented they are, the more space you will need to have. That costs you money. So you're going to want to defrag your indexes fairly frequently up here. But understand that fragmenting indexes can lead to long-running queries, which can cause you to get killed. So you're going to have to balance your index defragmentation with getting your resources killed. My recommendation is probably you want to defragment at a higher rate on Azure systems than you would on physical boxes to avoid the throttling, right? If you defrag, if it's a longer running defrag, you're more likely to get throttled. So you may want to do it more frequently, so it's defragmenting less and therefore running faster. But that's a dance. So there's not like I don't have a good guidance at X do this, at Y do that. I don't even have a good guess yet. But I would strongly suggest more frequently. All right. Hopefully, we've hit these goals, right? This was the goal of the presentation. Resources. You can go to scarydba.com/resources, and then you can get all the other three things that I mentioned here. There's links to them. The three things that I'm recommending is the SQL Server 2012 Query Performance Tuning book that I wrote. Most of that book, where it's not dealing with OS level stuff, is completely applicable to Microsoft Azure SQL Database. There's no differences. Same thing goes with Lewis Davidson and Tim Ford's excellent book on the DMVs. And again, as long as it's not talking about OS level stuff, it's completely applicable to what you're doing in MOSD. And then, still got the old name on it, I checked, the Windows Azure SQL Database and SQL Performance Scalability Compared and Contrasted is an excellent article by Connor Cunningham and a couple of other Microsofties that gives you an idea of the overview of stuff that you can do in query tuning in the MOSD databases as compared to the on-premise stuff. Here's my contact information. I'm not going away. We have 8 whole minutes left because I skipped running a couple of queries. So let's answer any questions anybody's got, at least on this topic.
So one is, please explain an example of the CPU cost is more at that time, what the actions we would have to take.
Well, if CPU cost is more, your choices are very limited, right? There is the ability, hang on, let me just switch over here and switch to here. And I believe scale, does it have it here? No, hang on one second. Let's go to, I'm going to switch subscriptions real quick. Bear with me. We'll go to that one. I believe I've got it set up here, so I do want to answer your question intelligently. I can answer it badly. Oh, nuts, I don't. Hang on, let's try it this way. New. Oh, nuts, it created it in the wrong place. Okay, I'm not going to be able to. There is a method you can do at scale if you're in a different. I'm in the northeast U.S. and it doesn't have this yet, but there is a new thing coming out from Microsoft called Premium, and it allows you to pick some additional CPU. Other than that, what you have to do is tune the query, meaning identify where it's running slow, why it's running slow. Does it need an index? Does it need a better index? Do you need to change the T-SQL? all the standard stuff. Have you updated your statistics? You're going to have to do all those things that you normally do for tuning queries. Just do them with the more limited tool set that you have within the MOSD.
The other question is, are the 3 database copies in sync? Is there any
Yes.
chance for a data loss? And what is the method used to keep those DB copies in sync?
Okay, the method used, I do not know. That is an internal Microsoft thing. They don't have it published. They don't tell us. We don't know. It is a form of replication, but again, it's not the replication that you and I know. It's something different. Is there any chance of data loss? On a committed transaction, no. They've got mechanisms in place to ensure that that does not happen. On any open transactions, it is exactly the same as if you had an open transaction in your system. If you lose that open transaction, you're going to lose that data. Right? That's just how it works. So that's, again, the emphasis, it's emphasized over and over again, and hopefully I've said it at least 3 or 4 times, you need good retry logic. Your application must retry, and it has to retry carefully. If it doesn't have good retry logic, you will suffer.
How do we schedule index maintenance?
Oh, that's a fun one. How do you schedule index maintenance? All right. Well, there is no scheduler, as we saw. We connected up there. So how do you schedule index maintenance or statistics updates or anything else for that matter? Okay, you've got options. Option number 1 that I don't like, but you can do, is set up schedules and connect up. I mean, as we saw, I'm connected out to Azure from my local database here, right? And so from here, I can go into this and set up a connection to set up jobs to go out to the Windows Azure SQL database. I could do it that way. I won't. The reason being is that all the transmission of stuff out, all the reports out, I'm defragging these indexes, I'm updating these statistics. Any information out, I pay for. Now it's pennies, right? But pennies add up to dollars, dollars add up to pounds or whatever, and off we go. I don't want to pay for that. So instead, what I would do is set up a Microsoft VM and then pay for a tiny VM, which is, yes, it's probably as much as the pennies, but probably a lot less, actually, and then have it do all the scheduling and everything up in Azure. Otherwise, Azure has a mechanism for doing scheduling, but it's very .NET focused, and you'll have to do a lot of programming. And if you're a lazy bastard like I am, you're going to want to go with VMs or local scheduler.
So I think that relates to the next question, which is, do you get charged for stuff that stays on the server, like the index defrags?
The processing, no, you don't get paid. You don't get charged for that at all. All you get charged for inside of the Microsoft Azure SQL database is storage, which is why you want to defrag in order to minimize the storage use, right? Because the more fragmented you get, the more space you take up, right? Because you're taking up empty space with the fragmentation. And so instead of paying for a 5 gig database, you got to pay for a 10 gig database, or instead of a 10, you got to pay for a 50 or 150. You don't want to. You want to pay for what you're not using.
And then, can the local SQL Server agent work with the SQL Azure for the scheduling, or do you also, that's where you just recommend paying for a VM?
I'd rather go with a VM. Can you do it from the local one? Yeah, you just have to set up the connection, right? It's setting up the connection string. And I mean, I didn't show you the connection, but I mean, it's trivial. It's just funky, right? Server name is this weird string. Port can be, what you want. 1433 is the default, but you can change it. And then it's a SQL login, right? You can't use an AD login, not for the Microsoft Azure SQL databases. You can set up virtual networks so that your VMs are set up through Active Directory, and you can access all of your VMs on Azure as if they were on your local network. the VM story is completely different. I like to tell this when the VM story is not. I shouldn't even say completely different. The VM story is dull because the VM story is the story you already know. So I don't tell that story because it's no fun. Once you set up the virtual network and you're connected up to these VMs, it looks like it's on your machine, right? It looks like it's local to you. There's no difference. But the Microsoft Azure SQL databases, they're more exciting. They've got limits, they've got differences, they've got changes, and they've got some stuff you got to do differently, right? So it's a bit more fun to tell that story. The VM story is dull. Tuning queries is tuning queries. Throwing hardware at the problem. If your 500 IOPS is not good, then stripe another couple of disks on there and get 1,000 or 1,500. You know what I mean? And off you go, right? It's dull.
So this is a follow-up to the question about having 3 databases being synced.
Sure.
Does the commit have to wait for all 3 databases to be synced before the transaction's committed?
Not to my knowledge, no. My understanding is that they've got like secondary caching and all this other stuff underneath the covers that, again, I cannot tell you the details of. But no, I've noticed no sort of delays on commits on. I've got production stuff. This is as much as I will show you of my production environment. Okay. That I have here, I'll zoom in so you can see it. I have a production environment. That's all I'm going to tell you. But I have a production environment, and the stuff I have seen, there's no delay on that. Not from that. Now, there are waits for the data transmission between the servers. You will see that, but they've got some sort of caching mechanism built in. And my understanding is once the data is saved, it's saved. But why and how and what exactly, you got to get a Microsoft person up against the wall and hold a gun to his head, because I don't have those answers.
Is it wise to use automated export to back up database in the configured databases?
Yes, because this is getting more into data administration, a little less into query tuning, but there is no mechanism for backup. What you have is the ability to export your database to a backpack file. And so the one mechanism you have for backup is that export to backpack. As a general backup mechanism, I would suggest you back up only to Azure Blob Storage. One, it's faster than backing up down, through the internet to your local machine. Two, you're not paying for moving that data out. And so you can back up to local blob storage once a day, once an hour, whatever, you figure out what's good for you. But, and then copy one of those down a week or something and only pay for that data out when you need to pay for it. Again, going back to the transaction stuff, small transactions, move what you need, move it when you need it. Do the same thing with backups.
And then this goes along with the SQL jobs. How do you set up the maintenance plans in Azure?
There are no maintenance plans
right.
not in the Microsoft Azure SQL database. There's no maintenance plan. Once you're back on the VMs, like I said, it's boring. Everything's exactly the same. And that's just no fun.
That's right. And that's basically all the questions. Let's see.
Okay.
I will copy the question log and send that over to you. So if there's any additional ones, you can answer them. This session is being recorded and will be posted on the past DBA Virtual Chapter archive page. I also wanted to let Nishan Sarab know that he is the winner of the $50 Amazon gift card courtesy of Dell, and we'll be sending him or her an email. And thanks again for joining us for this really interesting lecture on using the SQL database in the cloud. Thank you very much again, Grant, for a wonderful presentation.
Well, thanks. Thanks for having me. Love coming out. All right, so I'll give back control.